Hello, welcome to the video. In this lesson, we're going to be looking at section 11.1, where we're going to find measures of center and variation. In chapter 11, we are going to look at, be kind of introduced into the world of probability and statistics and um, looking at different data sets and how we can either describe what the data set is telling us, what we're supposed to find in these particular data sets, and there are some things in each of these lessons that we're going to be looking for. So in this first lesson, we're going to be looking um, at first these three main statistical concepts, these statistical definitions. So the first one we're going to be looking at is the mean. All right, so if you ever are asked to find the mean of a data set, you are essentially you're looking for the average of all of the data set values. So what you're going to do is you're going to add, you're going to add up all of the values in the data set, and then it gets divided by however many pieces of data that there actually is. All right. The symbol for mean is this. It's like this X with a horizontal bar on top of it. That's just the representation of the mean. Um, next definition we're going to look at is median. Median, when you take that same set of data and you put it into numerical order from least to greatest, you're going to be looking at the middle number. Uh, there's two different ways that you can look at a median. If your data set has an even number of values, you're going to take the mean of the two middle values. If it's an odd number, you're just going to take whatever the middle value is. So that's one thing you can look at. And then the last thing that we're going to kind of look at to start with is the mode. The mode is, if you look at a piece of data, it's what piece of data that occurs most often. There is the possibility of having one mode, which means you have just one value that shows up the most. You can have no mode, which means that there's no repeats, or you could have more than one mode. So if you see uh, two different sets of values that have equal number of repeated occurrences, you can have multiple values for the mode. Okay, so with that being said, we have an example right here where we have a piece of data. It says an amusement park hires students for the summer. The students' hourly wages are shown in the table. So here are the different wages. So some students get paid like 16.50, 8.75, 8.65, 9.20, so on and so forth. So we have all those pieces of data. They are asking us to find the mean, the median, and the mode of each of these hourly wages. So let's look at the mean first. So the mean here. So what you're going to do is you're going to add up all 8 pieces of data. So when you add them up, 1650 plus 875, so on and so forth, all the way down to $9.25. I encourage you guys to do this, add them all up, and you should get a value of 7720. Okay, so it should all add up to 7720. From here, you're going to divide it by the number of pieces of data there is. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8. So 77.2 divided by 8 gets you 9.65. So your mean, your average hourly wage for these students at the amusement park is $9.65. The median. So what you have to do first, in order to find the median, is you have to put all of these pieces of data into numerical order. So you got to find the smallest wage, which is what, 825. So I got 825, and what I'm going to do is I'm just going to kind of cross it out to let me know that I've got that. There's also another 825, so I write that in, cross that out. Looks like 845, cross that out. Next would be 865. Cross that out. 875. Cross that out. And then looks like what, 910. Cross that out. And then we got 9.225. And then finally 1650. So I got 1, 2, 3, 4, 5, 6, 7, 8. All right, so I got my 8. So I believe I'm good. All right. Because it's an even number, what you're going to do is, all right, so I got 1, 2, 3, 4. So here's a middle, 1, 2, 3, 4. Here's the other middle. So because it's an even number, these two values are going to help us determine what the median is, and you're simply going to take the average of those two values. So if you take 8.65, add to 8.75, you get 17.4, divide that by 2, you get $8.70. So my median is $8.70. The mode in this particular instance is what occurs the most. Well, they're the only ones here that occur more than once is 825. So $8.25 is my mode. Okay, so we found our mean, median, mode of these hourly wages. All right. Now, this question here, it says, which measure of center best represents the data, and they want us to explain. Okay, now, more often than not, the median is going to be your best um, measure of center for pieces of data. All right. Reason by this is, especially if you have a bunch of pieces of data that could potentially be outliers. So if you like here, you have this 1650 that really would enlarge the mean quite a bit. So for the most part, most students' wages fall in that middle category. So that is why the median is the best representation of this. Okay, mode is too low, and the mean the mean would actually put you somewhere right around here, which is not in the middle at all. So usually if you can get something that's close to the middle, that is the best representation, and that's usually the median. Usually. Okay, so here it says the park hires another student at an hourly wage of $8.45. It says, how does this affect the mean, median, and mode? And they ask you to explain. So basically, again, I would encourage you to do all the math and stuff like that, but I will give you just a brief. So I did this ahead of time. So the new mean with the $8.45 is going to make it the mean $9.52. All right. So what did that do to the mean? It actually decreased it. All right. Makes sense that it decreased it because it's something that was a smaller value than the original mean that was given to us, which was $9.65. The median in this case is going to be $8.65. All right. Again, another decrease. This would be what, a decrease of 5 cents. And then the mode we will say, is because there is another student that has $8.45 if you look remember from the data set. Now we have two modes, so 825, and then we also can say 845 now because there's a repeat there. So now the change now is, oh, now we have one mode and now we have two modes. So what it did, uh, what it did here is, yeah, there were some decreases in the mean and the median because of the the wages for 845 was, on the lower end of the wages, looking at it as a whole. But again, if you're still looking at trying to figure out which uh, measure of center best represents, it's still going to be the median. All right, because still 952 is still on the high end of the wage scale, and you know we're trying to find something that's in the middle. Okay. So still looking at that piece of data, here it says consider the data in example one. So the wages of the amusement park, they're asking to identify an outlier. How does the outlier affect the mean, median, and mode? And they're asking you to describe one possible explanation for the outlier. So for this situation, uh, we could say that the student that gets paid $16.50 is an outlier. All right, it really will skew the mean. All right, so I would say it affects the mean the most. I don't think it doesn't make that much difference in the median or the mode. It affects the mean the most. Would would the mean look closer to the middle values of the median? Probably, but that's why it is in fact an outlier. Uh, for part B, they ask you to describe one possible explanation. I could give you a couple. Maybe, that student's been there the longest, or they give that particular student some type of, they kind of manage other students at the amusement park, so they give them a raise of some kind. You know, there are several different possibilities that that person is making that much more money, but that is a possibility for that outlier. Okay, have another example. It says here it says two reality cooking shows select 12 contestants each. The ages of the contestants are shown in the table. They're asking to find the range of the ages for each show and comparing your results. So when you're looking at a range, so that's a new definition, that's a new form of measurement that we're trying to find. All you are going to do to find the range is you're going to look at your largest number and subtract it by the smallest number. And that's where you're going to find your range. So if we look at show A, to find the range of this, we're going to look at the largest number. The oldest person in this case, I believe, is 31. So I'm going to put 31, and that's going to be minus by the youngest person, which was what, 19. So 31 minus 19 is 12. So my range for the show A is 12. Show B, looking at this one, looks like my oldest person in that show was 48, and the youngest one is also 19. So 48 minus 19 gets us a result of 29. All right. Comparing the results, show A had range of 12, show B had a range of 29. That just means that uh, the ages in show B were more spread out. So that's what we can compare with that. The final concept that we're going to look at is a um, piece of data measure which is called standard deviation. So standard deviation, when you are looking for it, there are different steps to look at it. I understand that this formula right here looks very daunting, but once you break it down into the different steps, it really isn't that bad. It's very attainable to solve. All right, it just looks like a lot of work. I do understand. So the first step you're going to do is you need to find the mean of the piece of data. All right, so you're going to find the mean of the piece of data. Once you've discovered the mean, what you are going to do then is you're going to plug these pieces of mean into the formula. So what you're going to do is put it probably in numerical order. And then what you're going to do is you're going to take the first piece of data, whatever that is, subtract it by the mean, and then square it. And then that's going to be added by the second piece of data, subtracted by the mean, and then square it. And you're going to do that for every piece of data. And then that's going to be divided by the number of pieces of data in the data set. And then whatever that result is, you're going to take the square root of it. And then that's going to tell us what the standard deviation of our piece of data is. So in this particular example, they want us to find the standard deviation of show A from the cooking show from the example that we just looked at prior to looking at standard deviation. So the one that we're looking at for the range. So here, what we're going to do is, all right, so if I look at show A, and if you resort back to that chart, what I'm going to do is I'm going to put these values in just numeric order. So I got what? So when it was age 19, there was 20, there was 20, 21, 22, 25, 27, 27, two 29s, a 30, and a 31. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we got 12. That's how many that were in there. All right, good. So we got to find the mean first. So to find the mean, add all these up. When you add them all up, our mean is going to be what? 300 divided by 12, which equals 25. All right, so my mean age of show A is 25 years old. Okay, so to find the standard deviation, what we're going to do here, that's simple. I'm sorry, that's a bad symbol. I'm going to take the square root, and so I'm going to take a look at the first piece of data, so 19. So what we're going to do is you take 19 minus 25, which is -6. -6 squared is 36. Plus 20 minus 25 is -5. Square that, 25. Plus, it'd be the same thing, so it'd be 25 plus 21 minus 25 squared, that'll give us what, -4, so then, and then we squared, so it'd be 16. Plus 22, that'd be -3, and then squared would be 9, so we got 9. Plus 25 minus 25 is 0, 0 squared is 0, plus 27 minus 25 is what, 2, 2 squared is 4, plus 27, so that's the same thing, that'd be 4, plus 29, that'd be what, 4, so that's 16, plus 29, so that's also 16, plus 30 minus 25, square that, that's going to be 25, and finally 31 minus 25 is 6, and then we go 36. So I got all of those values, and then this is going to be all divided by 12, because there's 12 pieces of data. So add up all of, in this case, all of the red sums here. So it's going to be the square root of 212 divided by 12. So if I take 212 divided by 12 and I take the square root of that, my answer is about 4.2. So my standard deviation is a 4.2. How is that? What does that number mean? Or why is it relevant? So basically, it's telling you that 4.2 is what most people in show A will either be 4.2 years older than the mean and 4.2 years younger than the mean. Okay, so that's where most people kind of show up in. So basically, they're saying like, well, they're either going to be, you know, about 29 years old and as old as about 29 years old and is about as young as 21 years old. Okay, so here it asks you to find the standard deviation for show B in example 3. All right, I do encourage you to look at this. So I already did the math on this, and the standard deviation for show B is about 7.47. Okay, 7.47. They're asking you to compare that show A and show B, and what can you conclude? Well, the conclusion we kind of made when we talked about the range. All right, when we talked about range, we said that show B, the ages were more spread out, and we can make that same conclusion with the standard deviation. Okay, the ages are just more spread out. All right, so last thing that we're going to look at is talking about data transformations, uh, either using addition or data transformation using multiplication. All right, so what I what I want you to do is this: is here it says in this little here it says when a real number k is added to each number in the data set, it says the measures of the center of new data can be set up by finding adding k to the original measure of the center. The, right here it says the measures of variation of the new set of data are the same as the original measures of variation. Okay, what that is telling us is if we were to look at anything that's going to be added, so it's like mean, median, or mode, you are going to add whatever that is. So, for example, they're asked you to consider the first example, the example with the wages of uh, amusement park students. They're asking you to find the mean, median, mode, range, and standard deviation when each hourly wage is increased by 50 cents. So what I'm going to, so let's go back to the original. So I go to mean, median, mode, range, and standard deviation. Okay. So the mean was 965. The median was 870. The mode was 825. The ranges I just did, I encourage you to check. It's going to be 825 and the standard deviation is 2.61. All right, so um, I did those maths kind of early on just to save some time for the video. But again, I would encourage you to look at those things and make sure that those are in fact those said solutions. Now, when we look at when we look at uh, an increase of 50 cents, so what's going to happen now with the increase of 50 cents is this: your new mean is now going to be 10.15. It's an increase of 50 cents. Our median is going to be $9.20. Again, an increase of 50 cents. Our mode is going to be 875, an increase of 50 cents. But here's where it changes. Our range is still going to be 825, which was 0, and standard deviation is still going to be 2.61, which is 0. So if you noticed, the mean, the median, and the mode all increased by 50 cents, but the range and standard deviation didn't change at all. So something to something to think about. And that is being able to look at measures of center and variation. Hope this helps. Till next time.